Welcome to the Solving Quadratic Word Problems Day 2. Today we're going to be looking at max-min questions. So basically, instead of, find, the time that, the ball gets to here in the air and so forth, we're not going to be finding the x-intercepts of the zeros. What we're going to be doing is finding the maximum height that the ball got today, or the lowest part of like a bridge and so forth. Okay, so if we want to look at this visually, so again we have our parabolas here where we are drawing them opening down or opening up. Okay, so last day we were trying to find, okay, if it was like 60 meters here, what are, these two times, or, distances across the field or so forth. That's what we did last day. But today what we're going to do, so instead of finding like the x-intercept and zeros, what we're going to do today is we're going to find where is the max point, okay, where is the minimum point in this problem. And then again, what you're doing today is you're finding the vertex. So, like it could be the maximum profit or the lowest cost, or but in the end, you're finding some sort of max or min value. But in order to do that, if we have a standard form equation like right here, we need to get it converted to vertex form in order to find the vertex. So that's what you're going to do today. You're going to be bringing back that complete the square tool that we were practicing last week. And so that's what you're going to do, and then you're going to relate it to a word problem. So it might be a ball being kicked in the air. So you change this, this equation here will be the path of the ball in the air going like this, but then you're going to change it to vertex form, and then you should be able to find the vertex, and then you can tell me how high the ball got, how long it took to get to that height, and so forth, okay? So just like last day, we're going to start with some examples where the equation's already given to us, and then we're going to go through and find the max and min. And then there will be some questions where we aren't given the equation, we have to build it first, and then kind of go through the steps of finding the vertex, okay? All right, so here's our first one here where we're given the equation. So again, it's a ball being kicked in the air. And this equation represents the path of the ball in the air. So again, if it helps every time, just draw a diagram out so you can help visualize what you're doing here. Okay, so again, we don't know exactly where it was kicked from, but you could just do a rough estimate here and just kind of go, okay, it looks something like that. Okay, and so we have the h in the equation. It represents the height of the ball, and t represents the time that has passed. Okay, so basically you kick the ball, we start the clock, and then we're counting how long it takes to go through its path here. So in the first question here, and again, I know that the parabola opens this way because we have a negative here. Okay, and if you want to do a better sketch, you know that this 3 here is the y-intercept. So I guess I can readjust this and, write 3, so it hits the 3, and then it kind of goes like that, I guess. Okay, so so again, we're not trying to find the where we kicked it from, where it lands today. We're trying to find something about the maximum or the minimum today. So in part A here, it says what's the maximum height that the ball will reach. So basically we are trying to figure out right here, this value right here. Okay, so this value here, we're trying to find the height where the max is, right? Because that's the max. Okay, so that's the key too when you're going through these word problems compared to the ones that you did last day. You want to be looking for the words like maximum or minimum or smallest or largest area and so forth, okay? And if you see those words, then you know, oh, it has to do with, finding the vertex. And so therefore getting the equation to vertex form, okay? All right, so we'll start with the, the equation here. So we have this one here. So our goal is to get it to vertex form. Okay, so again, what that looks like is, you'll have some value, you have this x in a bracket, plus k like that. So, and then you can find your vertex, which is hk here. Okay, so that's your goal. So in order to do that, we have to complete the square. So I'll just show you a review what that is. So last day we did completing the square. So this is the formula note. So again, our goal here is to go from standard form to the vertex form here, okay? So what we did in order to do that last day, we follow this series of steps here. So I'll just kind of go through here and just do a review. So what you're doing is you're going to take the first two terms and create a perfect square. So when you take the x squared and the 8x, you're trying to think of, so what you do is you divide this number by 2 and you square it. Okay, so divide it by 2, you get 4, and then 4 squared is 16. Okay, so you add that third term, but then you also have to add its opposite to keep the balance, right? And then you write the plus 15. Then in the next line, you're going to take the first 3. This is a perfect square. So you factor it to here, and then you clean up this term. Okay, and that gets you to the vertex form. Okay. All right, so those are the simple ones where they're simple trinomials, but if there is a number in front like that, what we did was we divided it, that number out, okay, put it outside, and then we did completed the square here. Okay, so again, 6 divided by 2 is 3, 3 squared is 9. Okay, so then we subtract 9 as well, and then we carry that third term along. Okay, take the first 3, get it to, factor it to the perfect square, okay, because it's a perfect square, and then add the last two numbers, and then if there's a number, you just multiply it in. Okay, so that's what we're doing today. We're trying to get it to the vertex form. So again, if you skip this lesson, please go back and practice this one before you start the word problems today. Okay, so the other method that I showed you with completing the square is the area model method. So again, what you're trying to do here is you're trying to go through and do the same thing, but you're going to use the box method in order to get the perfect square here. So again, if you take the first two numbers, okay, so you put x squared in here, and then so you're taking 6 and dividing by 2, which is 3, so you put 3 and 3 here, and then you need to find that last term. Okay, so again, if you take the 3 and square it, you get 9, okay? And then you get your perfect square. And then you take the factors out, okay? Write these factors over here, okay? And then you need to make an adjustment. Okay, so the original was plus 2. I have plus 9 now, so what do I need to do? I need to subtract 7 on both sides, and then I'll get it back to here, which will be the vertex form on this side here. Okay, so yeah, so whichever method works, the formula way or the area model way, just make sure you are getting to the vertex form, okay? Okay, so I'm just going to convert this one here to the vertex form. So again, I see something out in front here, so a -1, so I'm going to divide that -1 out. Okay, so think that's the GCF, -1. Okay, so and then write the factor outside, and then write whatever else is inside here. So negative makes positive t squared. This becomes -2t, and that becomes -3. Okay, all right, and then from there, we're not going to factor this. We're going to create a perfect square here. Okay, so we're trying to think of, okay, so take this number and divide by 2, okay, and then square it. So okay, so if I take that number and divide by 2, I get -1. So again, if you want to do the thing on the side here, so b is -2. If I take it and divide it by 2, I get -1. And then if I square it, I get +1. So that's the third term, okay, to complete the perfect square. So that's completing the square. All right, so I'm going to put that 1 there. Okay, it's +1, but then I need its opposite, subtract 1, to keep the balance. And then I have the subtract 3 that was already there. Okay, so from there, you have your perfect square here now. So you could just factor it down. Okay, to there. Okay, so again, t minus 1. So if you factor it, FOIL it out, you'll get to here. All right, and then we have these last two here. So that's -4. Okay, all inside the square brackets with this negative outside, okay? All right, so we don't like to have two sets of brackets here for the vertex form. So again, remember there's a -1 out here. We are gonna distribute that 1 here, put it there, and multiply it here as well. Okay, so that negative goes right in front. I don't multiply it in, I just leave it. And then this negative multiplies by this -4, makes it +4. So look, I have it now in vertex form. Okay, so that's the same equation that we started with. So we had our standard form here, right? This was the standard form. I can, with this form, I know that it's opening down. I know the y-intercept is right here at 3, but that's about it, right? But then when I convert it to vertex form, I can find the vertex, right? There it is. That's the h, and that's the k right there. So what you're going to do, so hk, the vertex. Okay, so what it is remember, take the opposite of h out, so that's +1. And this, just take 4, and there's your vertex. Okay, so now if we go back to the diagram that we kind of made a sketch of here, so this is not to scale, but that would have been 1, and this would have been 4 right here. Okay, so that is 1, 4. All right, so we found a vertex, but we have to answer a question now. So the question in A was, what was the maximum height of that ball that the ball reached? Okay, so the height, the max height was 4. And then part B is, when did the ball reach that height? So it reached it at 1 second here, right? So this is seconds, yeah. All right, so let's make that final statement here. Okay, so the maximum height of the ball was 4. So it's good too to, like when you get the vertex like that, to actually write out, oh yeah, that, this value is the height, and this value is the time. Okay, so it's good to do that. So that when you're translating it into the final statement, you are putting things in the right spot. Okay, so part A was, what's the maximum height? So the maximum height of the ball was 4 meters. Don't forget the units. And the time of the maximum height was 1 second. Okay, so again, here, h represents the height in meters, t represents the time in seconds. Okay, all right, so there's example 1. Let's try the next example here. Okay, so we have one of those ladders on a fire truck, so an aerial ladder. They have the hose up there, and it's spraying water on a forest fire. Okay, so the path of the water is represented by this equation here, where h is the height in meters, x is the horizontal distance. Okay, that the water, is being sprayed. So we need to determine the maximum height of this the spray of the water if we know that that's the equation. Okay, so let's make a little diagram here again just to help visualize. Okay, so we have a rough sketch here. So again, it's negative. So we know that it opens down. And then remember, this is always the y-intercept here, right? Okay, so if we're making a rough sketch of our diagram here, so we know that, it gets to 6.75, and we know it opens down, so it looks something like that, okay? So, so with that, you can, think of it as that's where the top of the ladder is, and then the water is being sprayed onto the forest fire. Okay, so we know it opens down, we know the y-intercept, but I want to know where is the max, so say it's about right there, right? We need to figure out where that max is, that max height. So in order to do that, we can't find that from this equation here, the standard form. We need to take it and convert it to vertex form. Okay, so again, you need to be able to identify, like when you have a problem like this where it wants the max or min, then you know, oh, okay, so I have to use so here, if I wrote out the grasp method, okay, so we know we have our equation. What do we need to find? We need to find the max height. Okay, and then A, what's our plan? So last day we kept writing things like we need to factor it or we need to use quadratic formula. But today, because we need to find the max height, we need to complete the square. Okay, which means go and find the vertex form. Okay, so that's our plan of action. So you need to be able to select the right tool that you need to use in order to get to the answers in the problem. All right, so we need to complete the square. So we're going to go through here and convert this standard form equation to vertex form. So again, feel free to use whichever method that you are more comfortable with, okay? So I'm going to take out the greatest common factor here. So again, it doesn't matter if it's going to divide out nicely with the rest. Just take it out. We don't want a number or a negative sign in front of the x squared here in order to complete the square. So I'm going to divide that out to everybody here. Okay, and then rewrite what I have with that factor left outside of some square brackets. Okay, so here these will cancel out. You get an x squared. Okay, 4.5 divided by negative 2.25 is negative 2x. And this divided by that is negative 3. Okay, so it comes out to a nicer looking quadratic here. Okay, so so again, just because you see this, don't think, oh, I got a factor now. No, remember we are completing the square. Okay, so that's where you have to keep reminding yourself, this is our plan. This is what you need to keep doing, okay? All right, so again, if it helps you to underline things like this, then do it. Okay, so you're trying to take these two and create a perfect square. So again, our b is negative 2. So again, you don't need to write these, but if it helps, okay, you can do that. You're going to take the second term here and divide by 2, which is negative 1, and then you square it, which is positive 1. Okay? So that is that third term that you need here. So if I write this out, so the third term that you need is the positive 1, but then you just, to balance it out, you're going to put its opposite in, and then write whatever else was left in the equation here. Okay. All right, so, and then from there, you know that this is now a perfect square that you can factor. And there it is. Okay, and then clean these up. This ends up looking just like the previous one. Okay, but anyway, it's a different a value, I guess. All right, so from there, we're almost there. Now we're going to multiply this a value in, okay, because we don't want two sets of brackets if we want the vertex form. So that negative 225 just multiplies right out in front of this bracket here, x minus 1 squared. All right, and then the 225 multiplies with the 4. So negative times negative is positive, and it makes it 9, okay? All right, so there is now the vertex form. Okay, so again, you started with the standard form here. Okay, this was the standard form. Okay, you can find some information like the y-intercept, you know which way it opens, but the vertex form is great because it can tell you the vertex as well. You do know which way it opens, I guess. So with both of these, you can find a lot of information together, okay? All right, so the vertex, so there it is. Remember, this is the h, and that's the k. Oops, k. So your vertex here, okay, remember, take out the opposite sign of h, so it's positive 1, and this is 9. Okay, and then once you have your vertex, you can kind of go back and go, what am I trying to find here? Oh yes, so this is the max height. And then if this question wanted you to find how far along is the maximum height, this is the horizontal distance that matches. Okay, that's the x value. Okay, all right, so we found that, and then so it wants us just to determine the max height of the spray, so we can do a therefore statement right in the corner here. So therefore, is 9 meters. Meters, right? Meters, yeah. Okay, so that's what you need to do here today. So make sure to write a final statement and write your answer with units. Okay, here's our first example of where we're not given an equation, so we need to build it first, and then we need to go through the process of completing the square in order to find the max or min value that the problem wants you to find, okay? So again, because I know you did your homework last day, you were looking at, there was one question where it was looking at profit and breaking even and so forth. So I just wanted to show you that again if you missed that question. So again, if there's profit, and I think they were cutting the lawn and so forth. So they were making money, that's profit. And then X was I think they were charging a certain amount for each lawn that was being cut. So so depending on how much they charged, there was a certain amount of profit to be made. So there was a parabolic relationship between that. So basically, so if if you charge a certain amount for each lawn that you cut, there was a profit to be made. There was also, the startup costs, like you had to buy a lawnmower and you had to buy oil and so forth, and maybe advertise your business. So you had to pay some money out of pocket, so you were didn't have any money. Okay, so but at some point, once you start working and so forth, you're going to break even, and that's what these values down here were. Okay, so you were looking at the intercepts here, and this was where you would break even. Okay, so when you broke even, that means you didn't have any money in your pockets, but you also didn't owe any money. So that's why they call it breaking even. And so this is where you would have to find the zeros. Okay, so today though, we're going to be looking at, what can we do in order to make the most profit here? So we're going to be looking at the max profit up here. Okay. So just kind of keep in mind whenever if it says to break even, you're finding the x-intercept. So that means you're factoring or using quadratic formula. But when you're looking for, max profit, max revenue, all that stuff, you are looking at completing the square and finding the vertex form, okay? So there's just some words that will be thrown at you throughout the word problems here. So so just make sure you understand what they mean. So costs, so that's money going out for expenses. So like I said, you had to buy the lawnmower, you had to buy the oil, maybe you had to, take it to the mechanic to get it tuned up or something, and you had to make some advertisements so you could advertise your business, so people would, want you to come and cut their lawn and so forth. Okay, so there was some costs involved. Once you start charging and cutting the lawn and so forth, you're going to make some money, so that's the revenue. But so yeah, like here's the price, maybe the price of cutting the lawn and how many lawns that you cut. This is how you find the revenue. Okay, so that makes sense. So if you sell, I don't know, you sell 5 donuts, you make 10 cents a donut, then you make money. That's, you multiply those two together, okay, and get 50 cents. All right, so that's revenue. But then there's profit. Profit is when now your revenue, you're comparing your revenue and your costs, okay? So when we take that and subtract it, hopefully it's a positive number, so that means you're making money, okay? Otherwise, if it is a negative number, that means you're still in the hole here, paying for your costs, your expenses still. So we're going to analyze a business application today where we have a coffee shop and we're selling coffee. Okay, and so if you're wondering why the profit looks like this, why does it go up and down and so forth, right? It's because, like, depending on what price you decide to charge, there's some point where you can make a lot of money, you can make a maximum amount of profit. But at some point, if you charge too much money, the customers will stop coming and buying stuff for you, or they'll stop wanting you to cut their lawn. They're like, well, that guy's too expensive. Okay, so so again, but then at the same time, if you don't charge enough, you're not getting the maximum potential amount of money that you could make. So that's why these quadratic functions are really good with business applications and so forth, if that's kind of the field that you're thinking of. Okay, so anyway, just some simple introductory business ones that we're going to look at today. Okay, this is you. You have a coffee company. So right now you sell coffee for $2.60 per cup, and in general you're selling 200 cups a day. All right, so but you're trying to do research because it's always good to try to see if you can make more money and so forth. So you're doing a survey. You had a survey going, and you found out that so if you decrease the price by 0.05, so think of it as like 5 cents, right? So if you decided to sell it for $2.55 instead, you'll have 10 more customers, okay, or 10 more coffee cups that are being sold, okay. So you end up selling 210. And so for every decrease of 5 cents that you have, you will have 10 more cups sold. Okay. So knowing that, I want you to go through and analyze the situation and then actually figure out what's the maximum daily revenue that you can make in sales. And what price would the coffee mug have to be? So if we make a diagram here, so we're looking at okay, so for every decrease, the number of decreases that you make, so I don't know, let's call it X is the number of decreases. Okay, up to 5 cents or $0.05. Okay, so every time you decrease the price, what's going to happen to your revenue? Okay, so in general, we're looking at parabolic functions here. So here's your revenue. Okay, so this is the scenario. So again, if you start at a certain price, you start decreasing it, right? Decreasing the price. You're going to make more and more money because more and more people are going to come in and buy your coffee. Okay, so at some point you're going to make tons of money. There's going to be a max here. Okay, max revenue. Okay, but at some point, like if you decrease the price to a really low price, at some point you're going to start losing money to the point that you're back in the hole here, like we did, we're looking at here, because it costs money to buy the coffee beans, it costs money to buy the cups, it costs money to buy the machines, and the delivery of the coffee beans to your store and so forth. So you need to like not decreases so much that you end up losing money and then end up with lower revenue. Okay, so so just you want to go through and be careful here, and you'll break even at some point here. You still make money, but you want to figure out where's that high point, where's that max value, where's that perfect amount of drops of 5 cents in price that will get you the most amount of money. So we need to brainstorm here. We don't have an equation here to work from in order to find that max value of the vertex here. So what we need to do is just let's write down the info that we have. Okay, so what's given here? So we know that the price per mug is $2.60, right? So $2.60. All right, and how many customers will we have? Okay, so or just like the number of mugs sold, I guess, because I guess some customers might want to drink more than one. Oops, the number of mugs sold is just mugs. All right, so we have 200. Okay, if we have a price of $2.60, we'll sell 200. All right, so what's our revenue for that day? So how much money did we make then? We're gonna multiply those. So you just take $2.60 times 200 mugs, and you end up with $520 that day. Okay, so that's the revenue that you make. Okay, so but we're trying to figure out here what's the maximum amount of money. Okay, so so we're going to drop it 5 cents. Okay, so if you drop it 5 cents, that's $2.55. But what happens? So when we drop it by 5 cents, we get 10 more mugs being sold. So we'll sell 210 that day. So again, go through, multiply that out, and let's see how much money we have now. So you're thinking, well, if you drop the price, are you really going to make more money? Okay, so yeah, you do. You make a little bit more money because, when you drop the price, you had more mugs sold. Okay. All right. So so businesses do this all the time where they they do surveys to kind of figure out, if they could they, decrease the price, or could they increase the price, and would we still sell tickets and so forth? So can we make more money? All right, so here's another drop. So we go to 50 cents. So again, when we do that, we get 10 more customers. So now 220 mugs will be sold. Okay, so you could go through this whole process and keep calculating a bunch of values until you kind of hit a max and so forth. So, but I want to show you a way of doing this using quadratic functions. Okay, so what we're going to do here is you can keep going and calculating more if you want, but I want you to make kind of an equation that represents what's happening here, okay? So we're taking what's happening as we go step by step here is because like if we think of this as the number of decreases, I guess. So that's one decrease, that's two decreases here. So we're just taking the $2.65 and we are decreasing it by 5 cents, right? Every time. But depending on how many times we do this, we just have to multiply this 5 cents by X. Okay, so X, remember, represents how many times you decrease the price by 5 cents. Okay, so the price is just dropping by this, but we just don't know, like, again, if we went for a while here. So how many times do we drop it? Okay, so this is once, this is twice, this is X times. We don't know how many times we dropped it, okay? All right, so the number of mugs, what's happening with the number of mugs? Well, you started with 200, but every time you drop the price, right, what happened? You added 10 more people, 10 more mugs. So we're going to multiply that by X. So however many times that we drop the price, then we're going to add 10 extra mugs. Okay, so then from there, what we did was we took the price and multiplied it by the number of mugs, okay, and made the revenue. So that's all we're going to do here with our general equations here. We're going to take the price and we're going to multiply by how many mugs will be sold, and that will give us our revenue equation. Okay, so again, if you're wondering how this works, so if think of it as if I drop the price once by 5 cents, then I can put a 1 in here, so then I get 255. I would put a 1 in here, so then 200 plus 10 is 210. Okay, and then from here I can get the $535.50 for the revenue. Okay, so this is the general expression that we need for the revenue for this question. So, again, if you're a bit overwhelmed, just kind of keep going through with it. Stay patient. Just kind of keep going through with it. Once you see this one and then you have to try it again, it'll be a lot easier, okay? So what you've developed here now is you've developed, it looks like a quadratic function here. It's the factored form. Okay, so but what do we need to find in the end? We need to find the max revenue. So we need to find the vertex, right? The maximum. So we need to get the factored form to vertex form. But how do we do that? Well, we always went factored form. Okay, we can get it to standard form first. And from standard form, we go to vertex form. Okay, so we need to make this jump here. So we have it in factored form, go to standard form, then go to vertex form, then find your maximum, okay? So let's just do that here. So I'm just gonna reverse it here. Okay, so I want you to go through and just FOIL this out. So I'm just gonna go ahead and do that. And you just check your answer with mine. Okay, so we went from factored form to the standard form here. So I just used the FOIL method. You can use the area model method in order to get to the results here. So again, FOIL method is just, take this number times that, so that's 520. Take this number, multiply by that number, that's 26. Take this number, multiply by the 200, that'll be negative 10. And take this number last and multiply that by 10, and it gets to 0.5, okay? So then I put these two together, made it 16x in the middle, and then I just turned it around so that the x squared's first, the x is next, and then the 520 without any letters is at the end, okay? So it looks like the standard form. All right, so we're at the standard form now. Okay, so we're almost there. We just have to go through one more step. So you're actually cycling through now. You're going from factored to standard to vertex. Okay. All right. So that's why just be careful that you don't make any mistakes along the way, just because there's a lot of steps and so forth. Okay. All right. So there's the standard form. So again, to get to vertex form, I need to take this factor off. So I'm going to divide by that factor. And divide it through to everybody here. Okay, so negative, 0.5, negative 0.5, and negative 0.5, like that. Okay. Okay, so 16 divided by 0.5 is like multiplying it by 2, so negative 32x. And then negative 1040. All right, so again, you're not factoring. Remember, you're completing the square. So you're just going to go through here and find the third term here. That'll make the perfect square. So again, the middle term is 32. So if I take it and I divide by 2, I get 16. Then I take that number and square it. I'll get 256. Okay. So I take this number. Okay, we're adding our third term to make it a perfect square. But we're going to add its opposite so we don't upset the balance here. And then add the 1040. All right, so from here, complete the square. Okay, so that becomes that. And these two here become that. Okay, and then we're almost there. We're almost at the vertex form. Okay, so we don't want the extra square bracket. So we're going to multiply this 0.5 right there and to this one here. Okay, so there we go. All right, so now we have the vertex form. Okay, so we'll write the vertex out. So positive 16 and 648. Okay, so what do these numbers represent? Well, if we go back, so this is the x, right? And this is the r. So what are these? This is because it is the vertex. So again, we have our r and our x here. So x was the number of decreases, r was the revenue. Okay, so so this is a special type of revenue. This is the max revenue. So when you go through and find the vertex, you're finding the max or min. So this is the max revenue. This is the most amount of money that you will make when you kind of fiddle with the prices and decrease it. Okay, this value here is the x. X represented how many decreases. So this is the number of 5-cent decreases that you made to the price. Okay, all right, so now knowing that, let's go and answer our question here. It said, I want you to determine the maximum revenue from the coffee sales and the price per mug for this revenue. So we know the max revenue, so let's just look for the price, okay, per mug. Okay, so we know that it was $2.60 to start with, but then we're going to decrease it by 5 cents, right? But we're going to do this 16 times. So we're going to put the 16 right there. So if you do that, 16 times 5 cents, that's an 80 cent decrease by 80 cents. So that's what you're trying to find here. You're trying to find the I guess the price of the coffee mug now. If we were to decrease it 16 times, okay, you'll find that a price of $1.80 is what's going to get you the most money, so the max revenue for your store. Okay, so it's quite a big drop, but this is what you mathematically found will work. So you're going to gamble and try it out and see if it works. Okay. So again, anything lower than that will make it too low, and then you'll start losing money. So that's why you just got to be careful. Okay, so you went through the whole process of, finding what was given, and then we built, so we know what we had to find. So we had to find was this stuff here. Okay, and then here's our plan of action, right? Go for factor standard to vertex. Here's us putting that plan into action, and now we're at our therefore statement. So therefore, okay, okay, so put your units on. So $648 is the revenue that you'll make, and the price per mug. So the mug price, I guess. $1.80. So $1.80 is what's going to get you to that max price. Okay. Okay, here's our last example. So we're looking at a underpass that has a parabolic arc. So again, if we're making a diagram here. So let's see here, we could put it a few different ways we can draw this. So we have a underpass. So you can drive through here, and maybe there's like an overpass up here where the cars drive. Okay. Okay, but you also have a path that you can go in that's under the overpass. Okay, so this is the underpass. And so basically what you're doing here is you are trying to figure out if you can get this truck through here. So we have an arc that is 30 meters wide. Okay, so we know it's 30 meters wide. Okay, and we know that it's 10.8 meters high at the center. So we know that from here to here, oops, if that's straight, 10.8 meters. Okay, so that's the height. And then we have a truck here. So let's just look. So say if this was the truck that was, driving through here, that it's at 7.5 by 7.5. Okay, so let's just say it's a square shape here. So we're trying to figure out if this truck can make it through this, this underpass, right? So you can't go through here, but you can go in through here. Okay, so we're trying to figure out if that truck can make it through. So one year, I had a student ask me, like, as if a truck's going to actually hit that, and why would they drive it through, and so forth. And so, and what happened shortly after that, they asked that question. A couple of days later, a truck in London actually went through the Talbot Street underpass and actually hit it. So I'm just going to show you some pictures here. So here's a good one here where it actually has these little signs hanging down, so it's the right height. So if you're a truck driving through, you'll actually bang and hit those. It's a pretty large bang. And then so it's warning, like if you try to actually go, if you hit these signs right here, if you actually go through the tunnel right now, you'll hit the tunnel. Okay, so so they've tried all sorts of things, like putting all these signs up everywhere to say, hey, just if you aren't 3.3 meters, or if you're taller than that, you're not going to make it through. So yeah, like we've had all these incidents where the trucks have gone through. I think this might be a different. Oh no, it says it's Talbot Street. So they've gone through, and yeah, like I think this was the most recent one here. Where this truck got stuck and they had to deflate the tires to get it out. Okay, so it's kind of a funny. It's not a funny bridge, but it actually has its own Twitter account. So it says, sharing off the rooftops of trucks for decades now. So anyway, if it's something if you want to read up on it, it's something funny, I guess. So anyway, it happens. So yeah, it's important to, if you decide that you want to be, running your coffee company and driving the truck as well. If you're going to be trying to, take a shortcut through town, you want to make sure that truck will fit through the underpass so that you don't have to have these extra expenses now where you have to repair your truck and so forth. Okay, so we have our underpass here. We know the width of the bottom here. We know the height, okay, through the middle, and we know the size of our truck. So we need to make up a plan here in order to figure out if this truck can make it through. Okay, so I need to set up a plan here. So we're going to write down the stuff that's given to us. So we have this diagram here. We know the width of the tunnel. We know the height of the tunnel and so forth. So the way I have the diagram set up here, we can kind of just draw it separate. There's a couple different ways that you can draw this. You can draw it so that, this is what the tunnel is here. Okay, so we know that from here to here it's 30. And we know like the height there is 10.8 meters, right? So that's the height. And, this is the width. I don't know, we can call it X, I guess. Doesn't matter, I guess. But then the other scenario is, well, we can draw the tunnel like this and then put the height axis right there. So from here to here, that's 30. So this is 0. So if the width is 30, you know that from here to here, that's 15, and then this would be negative 15. And then this point right here where the max is the 10.8. So if you, you can do it whichever way. In the end, they would both work. I'm going to use this one here because I want to build an equation. We don't have an equation for this problem here. Okay, so our plan here, so again, what's required is we need to figure out if the truck can fit through. So we're just trying to figure out if we were to draw this, if this truck is going to make it through the tunnel here. So our plan here is to, find the equation for this this parabolic function here. Okay, once we find that equation, we need to drive the truck through. So we're going to drive it through the middle. We're not going to drive it through the side here. We're going to drive it through the middle, and we need to figure out the part that will hit the tunnel is this corner here. Okay, so this corner here. So we need to figure out what height that is right there. Okay, so we need to figure out what this point is here. Because if we can figure out, if we're going to drive it right through the middle like that, if we can figure out what this point is of the truck here, then we could figure out if it's going to make it through. Okay, so if we could figure out, again, where this point is on the parabola, and then, we do know the height of the truck is 7.5 meters, right? So we need to figure out if the tunnel is high enough at that point there. Okay, so again, we know that the truck is 7.5 by 7.5. So, even this way is 7.5, right? So if we look at, looking at halfway here, so half of 7.5 is 3.75. So, if we're looking at it from this diagram here, you know that if we were to drive the truck right through the middle here, right? So we would know that, okay, 3.75, so this isn't to scale, 3.75 of the truck is that way, and another 3.75 is this way. Okay, so we know that this part here is 7.5, right? 7.5 meters high. So we need to figure out at that point 3.75 on the parabola, is it higher than that corner of the truck? Okay, that's what we need to figure out. But we can do all of this once we get the equation. So let's do that, and then we'll come back and look at this picture again. Okay, so in order to get to the equation here, there's, again, you can look at it from this perspective or this perspective. I'm looking at, well, this diagram here. So I know that this is 30. I know that this is 0. I know that the height is 10.8. Okay, so I know the height here. What would halfway be, though? Okay, so what would the vertex be here? So halfway between 0 and 30 is 15. So you actually know the vertex now, so it's 15, 10.8. So there's the vertex. So you can build an equation with this one. if you want to use this diagram instead, well, you can build a factored form. Okay, so you know the two x-intercepts, then you also know another point. You should be able to build your equation as well. So just, pick one way and just kind of make it. I'm going to just use this one here. So I know I have the vertex, so I can build a vertex form equation. Okay, and so again, there's the vertex right there. There's HK, and then I do have another point, so I can use this one, 30, 0. Okay, so I can use 30, 0 for my other point, which is my XY, and then I just got to figure out my A value here. Okay, so Y is 0, A we don't know, X is 30, subtract H is 15, plus K, which is 10.8. Okay, so that becomes 15 squared. And you would write 225A. Okay, so that becomes 225 times A is 225A. All right, let's go through and solve for A. So we'll boot the 10.8 over. So let's do that now. So negative 10.8 and then 225A. Okay, and you'll get a value of negative 0.048 like that. Okay, and so what you'll get from there is, okay, so now you build your vertex form equation. And you can use this to help you find if the truck is going to be large enough. Okay, all right, but before we do that, I'm just going to go through and show you how to build an equation when it's looking like this. Okay, all right, so here instead of starting the overpass at 0 and made it to 30, we made it so that it kind of went halfway. So it's a width of 30. So 15 will go this way, negative 15 will go that way. So because we have the zeros here, we can build the factored form instead. Okay, so we have, the S's, the S and the T here, and we have our point XY here. Okay, so we know that this point here, the top part of the underpass is, the height is 10.8. So we're going to go through and fill this in. So we have Y is 10.8. Okay, so we don't know A, we know Y, X is 0, S is negative 15, so I put it in as the opposite, and so forth, okay? All right, so now I'll keep going. And you'll find that the A value is coming out to being the same as what you did on the other side here, okay? So A ends up being negative 0.048, okay? All right, so now we have our standard form equation that we can use to model the underpass. Okay, all right, so if we draw that diagram again, so we'll kind of finish this one off first and then we'll come back to this one. So we have our underpass drawn like that, so we know that this was 15 to negative 15, okay, but still makes it a width of 30. We know the height here is 10.8. So what we're doing here is we're trying to now figure out if the truck is going to fit. Okay, so we're putting the truck through here. So again, the truck is 7.5 feet wide, but again, if we just take it, like put it at 0 here, halfway, this way is 375, this way is a negative 375, to make it a total of 7.5. Okay, so putting the truck through, we know this point right here is 3.75 and 7.5. Okay, because we know the height of the truck is 7.5. Okay, and then again, we know that this edge of the truck is going to go in from, like again, this is the 0. We're going to go in 3.75 meters this way, and it's going to go through at this point. So we need to figure out right here in that same corner of that truck if the tunnel is tall enough, okay? So again, we know that that point there is 3.75. We need to figure out what the height of the tunnel is right there. Okay, so that's why, so we're going to use our equation to figure that out. Okay, so if that height there for the tunnel is higher than 7.5, we know the truck is going to make it through safely. Okay, so we're going to use our equation again. So this is us just now trying to find y. So if I know x, can you find y using the equation here? So 3.75. Okay, so then you end up with multiplying all of these together. That's negative. Okay, so if we multiply all those together, we'll get positive 10.125. Okay, so that's the height right there. So 10.125. So since it's high enough, that truck is going to make it through safely. Okay, so yeah, so can a truck that's 7.5 by 7.5 tall make it through the underpass? Yes. Okay, so make it through safely. Okay, so now that we've seen that with the factored form, let's go back to our vertex form that we built here. So again, we were assuming that the truck was going in, so the underpass starts at 0 and goes to 30. So if we're putting a truck through here now, let's visualize that. Okay, so again, we're going to put the truck through the middle because again, that's where the most space is. So if we have our truck here, okay, so again, we know that this is 0, that's 30, we know the height is 10.8, okay, we know halfway is 15. Okay, so if we're putting a truck through that's 7.5 meters, or sorry, yeah, meters wide, sorry, are we looking at meters or feet here? Oh, meters. Okay. So what we're doing is, so again, you know it's 7.5 meters wide. So if we have 15 here, remember halfway is 375. So if I add 375 to 15, this point right here will be 1875. Okay, right there. So the truck corner here is 1875. And then again, if you wanted to figure out where this was, you're going to subtract 375, which is 1125. Okay, so there's the truck. It's going to pass through at 1125 on this point here, at 18.75 on this point here. Okay, so we know that this corner of this truck has the point 1875, and then we know the height is 7.5. Okay, so there's that point. So again, just like with the other one, we need to figure out, okay, so the one that matches right there, and again, you can check on this side if you want to, and same with this one, you could have checked on that side. So at 18.75 meters here, we want to see if the truck or if the underpass is high enough here. Okay, so we need to figure out the height here. So same thing, we're going to plug it into our equation with our vertex form equation that we built here, and we're going to find the y value that works with 18.75. Okay, so there's our equation. So we're going to plug in the 18.75 here, subtract by 15. Okay, square it and multiply by this and then add the 18. Okay, so let's just do that right now. Okay, and we'll find that the y value here is just like the one over on the other side. Okay, so we know that it is tall enough for the truck to make it through safely. Okay. All right, so again, a tricky one. This is, again, why if you're just feeling really overwhelmed in these lessons, it's just we left these ones till the end because I wanted you to get your skills up on how to build the vertex form, how to switch between forms, how to, find the vertex and understand what's going on with the x-intercepts and so forth, okay? All right, so now that you've seen this one, you should be able to do another one if I change the number. So just kind of take a second to review, decide which method that you like better, and just try them out again. Same with the coffee example here. Just go through and kind of look at how it was set up, and then you should be able to do this again just with different numbers, okay? But hopefully overall, like these ones where I did give you the equation, it was okay to convert it to vertex form and then find the vertex and then make your therefore statement. But yeah, but again, if you did skip the complete the square lessons the other day, please go back and do those first and then tackle these ones here. All right, okay, so that kind of takes us to the end of all those tough word problems with quadratics. Next day, what we're going to do is we're just going to have another day where we practice these, but I'm going to throw all of the different ones at you where, sometimes you have to solve for the x-intercepts. You have to use factoring or quadratic formula. Sometimes you need to find the vertex form and then find the max min and so forth. So you just need to get practice with these so that next day you can kind of determine what's the best plan that you need in order to solve the problem. Okay.